In today's video, I'm going to show how to build a vacuum tube at home. These are triodes, and I had 2 attempts already. And in this video, I'm going to show how I built a better version of this. But first, let's look at how I built these, and then I go over the construction step by step, how to build a triode with pretty basic tools actually. So in a triode, you have a filament, a grid, and a plate. And by putting a voltage on the grid, you can control the current flow from the filament to the plate. And that's how a triode works. This is basically the same as a transistor, just that back in the day they didn't have the possibility to manufacture semiconductors. So they basically accomplished the same task as a transistor, just with the method of using a vacuum tube. So this is the first vacuum tube I made, and you can see here you have the filament on this side and the grid in the middle, and on the back side you have the plate. So the problem with this vacuum tube is I used a grid for covering windows or whatever, and this stuff is very dense, and the grid in a vacuum tube is not supposed to be that dense. So I couldn't get an electron flow, a good electron flow between the filament and the plate. Also, I poured some epoxy into the base to strengthen the base a little bit, but when I heated it up, the envelope cracked, and that was the end of this tube. But it wasn't that good to begin with, so I made a new one. So this is the second vacuum tube I made, and it's a bit hard to see because of the first problem. I made the filament a bit longer to increase its resistance, and it's now touching the side of the tube, the glass wall, and it's coating the wall in tungsten, and that's like the color you see. That's probably also not great for the tube, but you can see I made the grid a bit more spaced apart. I made the grid myself this time, and it's a bit less dense. And this tube actually works, it's still working, but in this video I'm going to show how to make an even better one, which also hopefully won't have any problems anymore. So to start making the vacuum tube, I'm going to start with making the base. And I think that's the most tricky part, because the base needs to be vacuum tight, and you have to melt in the wire in a specific way to get this right. So it's a bit hard to see, but for the base to be vacuum tight, the wires in the glass need to have a golden yellow color. I think it's pretty obvious here in the middle. So a while ago I already made a vacuum tube. It was a very basic X-ray tube. And in this video I used some tungsten wire and I removed the oxide coating with some potassium nitrate. And then I sealed it into a piece of glass, in a pretty long piece of glass. And yeah, this sort of works, but it's not the best method. I basically relied on having a long piece, and some section will be this golden yellow color. And what I did now is I figured out how to actually make a shorter section, like what is this, a centimeter, work, and it has the golden yellow color all the way through, and this already works to be vacuum tight. So I have here a piece of tungsten wire. This is 0.4 millimeter tungsten wire, and this is approximately 5 centimeters long. And I will heat this up very hot to drive out any oxygen or water that's on the surface. And then I will dip it into the potassium nitrate and then just wet it with the potassium nitrate, and this will get rid of the oxide that's on here. It's probably a bit hard to see, but the original tungsten wire is black from this black oxide coating, and the wire is now silver looking, so we removed the original oxide coating. And the next step is to reintroduce a thinner oxide coating by passing it through a very small flame. So this is more or less how it looks if it's not oxidized. And over here I over-oxidized it a bit, but the color blue is still okay. And ideally it should be like golden yellow, like over here. And then it's perfectly fine. Next I'll put this borosilicate glass tube on the tungsten wire, and then I'm going to melt it as hot as I can so the glass will bind with the oxide coating. Alright, this is how it looks. You kinda have to put some light on it to see the color, but the bottom one is the one I just made, and the top ones are some to compare, and it looks pretty good. It needs to be this golden yellow color, and then the seal is alright, and it will hold the vacuum. When I have 5 of these borosilicate to tungsten seals, I'm putting them into this graphite block that has some holes cut in, and then I'm going to melt them together with this torch. This makes it a bit easier to handle all the electrodes so they're in one package. This now has to get melted into a glass tube, but before that I'm putting a piece of glass tubing on a drill, and I'm shaping this with a piece of graphite so it has a lip to it. And this is for placing the tube or the stem on the vacuum tube envelope later on. And then I'm cutting a piece that is a similar length to the vacuum feed-throughs that we made, and then it can be put over there and then melted together. This is the stem that I made, and one problem with this method is that you kind of have to get into this space here with the torch, and you necessarily attack the tungsten a bit, and then you have some residue on here on the glass, and this might be conductive. I'm going to clean this up with some hydrochloric acid, but yeah, I have to figure out a better way so the tungsten is not exposed. I tried to make the bead seals a bit higher, so it's like here, and the glass is sticking out a little bit where it's melted, but this didn't really work. Alright, I cleaned it with hydrochloric acid, and now I'm going to crimp on some nickel wire. I could probably also use copper wire, and I'm going to crimp this on with a piece of nickel, and then I will spot weld this on the contacts that will be on the outside of the tube, and this will make it easier to attach some alligator clips or whatever, because you can bend the nickel really well, and the tungsten you can't really bend, and they're pretty close together. Alright, the nickel wire is welded on the outside pins, and you may or may not notice that the stem is not the same. That's because I had 2 failures. One, I tried to move things and a pin broke off, and the second one I actually captured on camera. The spot welder was somehow too powerful and welded off the pin here. So next I'm going to put the filament on, and the filament will be a very fine tungsten wire. This is 0.05 millimeters, and I'm going to put this across a structure that I made of stainless steel wire, and I'm going to weld this thing onto one of the pins, and then the filament will be between here and one of the pins down here. And I'm going to wrap the tungsten wire around a very small drill bit to make a spiral, so it's like a filament. Alright, that's the filament. It's a bit hard to make with such a thin wire, but I'm going to spot weld it now between here and the pin down here. Alright, it looks a bit ugly, but it serves its purpose. If I would build a light bulb, I would be done at that step and I would seal this in, but I'm not building a light bulb. I'm building a triode, so I still have a bunch of steps ahead. Now, different to a light bulb, the important thing coming off of this filament is not light, but for the triode it's electrons. And I could leave it this way, just the filament, but there is a way to increase the amount of electrons coming off of the filament. And that's by coating this in barium carbonate. So what I'm going to do is, I have here a barium carbonate solution. It's not really a solution, it doesn't really dissolve well into water, but I put some in water and I'm going to coat this with the barium carbonate, and then I'm going to dry this a little bit in the torch, and later in the vacuum I'm going to heat this filament up, and then this barium carbonate will be converted into barium oxide. And barium oxide is a very good emitter of electrons for this filament, and this will increase the conductivity when we put a voltage across the filament and the plate. Okay, this was kind of a failure. The barium stuff is not sticking to the filament, and yeah, also I tried to heat this up. I did get a few drops on here and tried to heat it up in the torch, not too much, but it got so hot that the filament is now a bit deformed. I'm not sure how this will be in the operation, because this filament will be hot anyway. If this is going to expand and the coil is getting so loose that it's going to touch stuff. But I guess we will see, and I will continue with this anyway now. Alright, this is going to be the grid of the tube, and this is just a stainless steel wire wrapped around a 9.5 millimeter drill bit. And this is going to get placed over the whole filament assembly and then fastened in at one of the pins. Alright, the grid is on. By the way, this design with the spiral as the grid is based on the YouTube channel JD Flyback. I think I mentioned him before, and he made a very similar tube with having the grid like the spiral, and then the plate will be also around, and this will make the whole thing a bit more compact and more efficient. Alright, before installing the plate, I'm going to put this thing in. And this is a filament from a 0.1 millimeter titanium wire. And I'm going to put this between one of the filament connections and an empty pin. And this filament will be later used instead of a getter. And a getter is for removing any rest gas that's in the tube. And titanium is very reactive when it's heated, and this is perfect for that. Alright, this is the last piece, the plate. The plate is a round cylinder out of stainless steel, and I spot welded some a piece of stainless steel wire on there. And now it's going to go over there, not touching the grid. And then the tube is basically done. And the next step is to make an envelope for the whole thing. This is very close together and a bit wobbly, but it works. Alright, now to the envelope for the triode. I'm using a test tube, a borosilicate test tube for that. And these are a bit small, the ones I have. And I couldn't make this smaller really so it can fit. So what I did is just blew into it while heating it up to make the test tube a bit wider. And it's not entirely even, but it's fine. And I made an evacuation stem that's going to attach here on the side. And I'm going to cut this here so the triode assembly can fit down in here. So I got me some mica sheet, which is some mineral material, and this should be vacuum compatible and heat resistant. And I supported the elements in the tube in there with cutting like slots in there and then pushing it in. And now everything in the tube should be centered and shouldn't short out. Alright, I put everything together now, off camera because I was a bit impatient, but I put the evacuation stem on the envelope and put the envelope on. Also, the evacuation stem has a 1926 ground glass joint, and I removed a bit of material there, and then this fits on a KF16 vacuum flange. And that's how I'm going to connect this to a vacuum pump. So unfortunately, after I sealed the tube, I saw that there is a piece of the filament that's shorting out the filament itself. I hope I can just put a bit of current through there and it will burn itself away or something. And then we have a filament again, else this is a problem. However, I already made another one, this time with the filament as a straight piece of wire. So this is unlikely to short out. So that's the plan B if the other one fails. So what I'm going to do now with this one is I'm going to put this on the vacuum pump. And I'm going to leave it on there for a while so all the air in there can be removed. And then I'm going to heat this up with a flame, with the torch a bit. This will get rid of any surface moisture that's stuck on the glass or whatever. And I'm going to heat up the filament as well to hopefully get rid of the short and heat the filament up as well. So any contamination that's stuck on there gets loose and gets pumped out. And then I'm going to seal this tube off. Alright, the vacuum tube is done, and the last thing that I have to do is heat up this titanium getter that I put in there. I already did this while pumping down, but I will do this again now, and this will absorb any gas that's still in there. Alright, I've been messing around with the tube for a while, and I've put together sort of a tube amp. I have no idea how to build a tube amp and just put together something that sort of works. And as you can see, it's not working great. I have both traces set to 2 volts peak to peak, and the input trace is the blue one and the output trace is the yellow one. So yeah, the output is lower than the input. I don't know if that's just me being bad at building a tube amp. But yeah, it's working. And I can, if I turn this on, I can adjust the filament current. The filament current is supplied by a step-up boost converter, and if I turn this down, the output disappears. So yeah, turn this up again, and then we have our output sound wave again. The high voltage is coming from this module. That's, I think, 400 volts. And yeah, that's basically it. I'm using a cheap MP3 player and just playing a 500 Hertz sine wave so we can see the trace. Alright, that's it about building this vacuum tube. I have to see what I will do with this in the future, if I actually get to build a tube amp, but I'm kind of done with this now and I want to continue with some other projects that I have planned.